Welcome to List and Range lecture. So lists can contain a collection of values in square brackets. Each value can be a float, int, string, or variable. Each value in a list is called an element. A list can contain nested lists, tuples, sets, dictionaries, series, or data frames. And the interesting thing about lists is that they can be mutable. So the elements within a list are mutable, unlike the elements in a tuple or string which aren't mutable. So as an example of mutability within a list, let's say we have num, which is a variable name for our list here, which contains three elements, which are 10, 20, and 30. And let's say we want to index by 0 to grab the number 10 and change that to a string of hello. As you can see here, we've reassigned the elements to be hello as opposed to 10. And then lastly, we have range. And range generates a specified list of numbers and is used frequently within loops. So let's start off with range. Let's say we do range 5. And as you can see here, we have 0 and 5. So if we want to actually see what's going on, simply wrap list around it with parentheses, and we have 0 to 4. So notice that it doesn't include the number 5 here. So if we were to change this to say 10, it doesn't include 10, it only goes up to 9. If we wanted 10 as well, we put 11, but of course that doesn't include the number 11. So if we were to do, let's say 0, 11, and we wanted to go up by a step size of 2, this will give all the even numbers. So 0, 2, 4, 6, 8, and 10. And if I were to change it just to the odd numbers, we'll start with 1 instead of 0. And then we have 1, 3, 5, 7, and 9. Okay, and let's say, for instance, I were to change this to 10, 110, and increment by 10. So starting at 10, we'll go up all the way to 100, and we are incrementing with a step size of 10. As you can see here, 10 all the way to 100 with a step size of 10 each time. Okay, so moving on from that, let's say we have numbers equals list, range, 10, 150, and then 10. And we'll do numbers, as you can see here, similar to what we had above, 10 all the way to 140. And if I were to do type numbers, we've got list. So this tells you what type of data we're dealing with or what type of variable. And if I were to do just simply empty list, we'll also get list as well. Okay, so just always remember that a list always contains square brackets. Okay, let's say we were to do nested list equals sort of square brackets, and then we'll do a nested list of 1, 2, 3, then 4, 5, 6, and then lastly 7, 8, 9. And I'm going to do nested list. As you can see here, we have the three nested lists. If I were to index, we get 1, 2, 3, 4, 5, 6, and lastly 2. We get the final nested list. But let's say, for instance, I wanted to, instead of having just simply 3 elements, I wanted to say 1,000 or 1,000,000 or 1,000,000,000. Well, typing that up can be extremely time-consuming and frankly totally impractical and impossible to do by any human. So one way to overcome this limitation is, let's say we were to do nested range, and we can do square brackets, of course, list range. We'll do the exact same output here, so 1, 4, and then list range 4, 7, list range 7, 10, and we'll just put that down to save some space there. And then nested range. As you can see, we have the exact same output as we had with our previous example of nested list. Okay, and we could also just change this to say, for instance, 11. We'll do, actually we'll change that to 10, 21, and we'll do 20 and 31. So now you can see that we have a total of 10 elements within each of these nested lists, which of course would have been extremely time consuming to type up. Okay, so moving on from that, what we're going to do now is create a variable called basket. Basket1 equals 1, 2, 3, 3, and 4. And if I just move that aside there, okay. And let's say if I do basket1.tab, and as you can see here, what we have is all the available methods and functions that we can apply to our variable called basket1. Okay, and what we're going to do is append .tab, and let's say I want to add in 55, and it will add on 55 to the end of our list. We'll do basket1. Here we have 55 added on. Okay, great. But if I were to do basket1.append again, let's say 80, do basket1, you can see 80 is added on. Let's say I want to remove this number 80. Well, what it does, if we use the pop method or function, is that this will remove the final elements from the list here. And you can see that the 80 is now removed. And if I were to do basket1.insert, this will allow me to put the number that we choose into a specific location within our list. So if I do 2, 100, and then I run this, you can see that the 100 is now put into a specific location as opposed to being put on the end of our list. And if I were to simply do basket1, 2, because this number here is the index, we're replacing the 100 into this list. We get 100. Okay, so the index number for 100 is 2. And let's say I wanted to, for instance, arrange the numbers from lowest to highest. Well, we do sort, we'll do basket1, get 1 to 100. And also note that if I were to do this, just comment this out here by control and /, you get function list.sort. So if you want this to operate, you have to make sure that you put the parentheses here. What we can also do, if I uncomment that, is reverse the arrangements of the numbers from, instead of it being lowest to highest, we can do highest to lowest. So you have highest to lowest here, 100 all the way to 1, but we'll stick to lowest to highest. Okay. And now moving on from that, we'll do basket2, and that's going to equal, let's say, 10, 20, 30, and then we'll do basket1. So it's a nested list. Basket2, and you can see here we have our nested list. If I were to do 0, we should get 10, 20, and if I do 2, we get 30, and if I do 3, we'll get the nested list of basket1. Another way of going about this is -1. So this is counting backwards. So when we're counting from left to right, it's 0, 1, 2, 3. But if we're counting from right to left, it's going to be -1, -2, -3, -4. So if I were to do -4, we get 10. And if I were to do more than that, we get an index error because there is no -5 here. Likewise, if I were to do 0, 1, 2, 3, 4, this will also give me an error as well because it's outside of the index range. Okay, so moving on from that, let's say I were to find a particular number. Let's say if I go back to here, and let's say I had, instead of it being a total of 6 elements within this nested list of basket1, what if there was 1,000,000? And what if I didn't know how many there were, but I wanted to find the final elements within my list? Well, what you can do is just simply -1, and that grabs the final element, in this case 100. Or I could just simply do 5, and there you have it, 100 as well. So let's say I do basket3 now, and we'll create a list of strings, in this case fruits, so apples, pears, berries, and we'll do bananas. Do basket3, There we go. And if I were to do basket 4 equals, in square brackets, basket 2 and basket 3, we'll do basket 4. As you can see here, we have multiple nested lists. In this case, we have basket 2 with basket 1 inside of it, and then we have baskets 3 inside of basket 4 as well. Okay, if we're to do 0, we get our nested list of basket 2 with the nested list of basket 1. If we do -1, if we do -1 again, we get 100. Okay, so moving on from that, let's say for instance I wanted to add certain values. So if I want to add 30 with 55 to make 85, what I can do is 0, and then do 2 here, then plus basket 4, 0, so I can grab the basket 2 nested list, and then I want to do, let's say -2. Just double check this, so 0, and then I want to do 3 here actually, so 0, 1, 2, 3, and then I want to do -2, and that should give me 85. 85. Okay, great. So moving on from that, let's say I were to do basket 5 equal A, then we do 1, 1, 1, 1, 3, 3, 3, 3, 3, and we'll do 50, 50. And if I were to do basket 5.count, let's say A, we should get 3, so it tells me how many elements there are within the list that contain the A string. Of course, if I were to do, let's say B, because there's something inside of it, I get 0. And let's say I do 1, I get 4. If I do 3, I should get a total of 5. And if I were to do 50, I should get 2. Okay, so moving on from that, we'll do basket 6 now. And that's basket 6 is going to be equal to A, lowercase, B, C, D, and we'll do 10, 20, 30. We'll do some booleans of true and false. We'll just do another line here to save space. Then we'll do -1, car, -2, bar, -3, star, and we'll do, let's say we print len, see how many elements we have here. There should be a total of 16. Excuse me, it's a total of 15 here. Okay, so let's say we were to do basket 6, and we wanted to get only the integer values, the positive integers, as opposed to the negatives. So it's 10, 20, and 30. Well, all we do is 0, 1, 2, 3, 4. So if I were to do 4 here, we get 10. And if I want to get the remainder here, then I simply do, it should be 7. There we go. So we have 10, 20, and 30. And if I were to, looks like I missed out a number here actually. So let's just add 40. That's why I said 16. So excuse me there. And I do 8. There we go. So we have all of our integers. And let's say I were to do basket 6, 10, colon, 2. So what's happening here is that the 10th element is, in this case, it's going to be just check that, -1. And then it's grabbing each second element. So we start at 10, which is going to be the index of -1. And then we go up by 2 each time. Let's say I wanted to just get the car, bar, and star. Well, we know that -1 is 10 on the index. So if I were to do 11 instead, we should get car, bar, and star. Car, bar, and star. Okay. And if I were to do basket 6, let's say 15 minus colon minus 1, this is going to start with the final element. In this case, it's star, and we're counting backwards, so it's going to reverse the entire list. So as you can see, instead of it being A all the way to star, it's now star all the way down to A. And I can also grab the second element of each one. So instead it would be star, bar, car, false, 40, 20, D, and B. As you can see here, star, bar, car, false, 40, 20, D, and B. Okay. And let's say, for instance, I were to do basket 6, 15, colon, 10, colon, minus 2. And as you can see, what's happening is that it's reversed the output. So instead of it being car, bar, star, it's now star, bar, car. So we're starting with 15, and we're going all the way down to 10. In this case, it's going to be, of course, number 1, or minus 1, excuse me. And then we're going by star, bar, car. Okay, but if I were to change this to 9, excuse me, 8. Now there we have it, we have false. And if I were to do basket 6, 15, we get star. Okay. And lastly, let's say I were to do colon, so 10, colon, 15, 2, and I should have a square bracket here. So we're getting all the negative values there. Let's say I wanted to just show the mutability. So if I go to basket 1, and let's say I wanted to change 100 into, let's say, the string chips, and I do basket 1, we now have chips instead of 100. And this is what's called mutability, as I've shown at the beginning of the lecture. Okay, so that concludes my lecture on lists and range. I hope this has been insightful, and if you have any questions, feel free to ask in the Q&A. Thanks. Welcome to Tuples lecture. So tuples are similar to a list in that it contains a collection of elements, but in this case it's within parentheses as opposed to square brackets. The elements in a tuple are immutable, unlike a list, and tuples only has 2 functions, which are index and counts. So if we were to do just simply type and then empty parentheses here, we'll get the output of a tuple. And let's say we create a tuple now, so tup1 equals, and if we were to simply do 40, 50, 60, and 70, and then do tup1, we get the parentheses here automatically added around these variables. And if we were to just check and do tup1, we get tuple as the type of variable we're dealing with here. However, what we could also do is say tup2, and we just do simply 100, all we get is just 100 rather than a tuple. But if we were to put another variable here as well, or rather another integer, then we have 2 elements here, and then it automatically wraps around these 2 elements as a tuple. And what we can also do is convert the tup2, the tuple, into a list. So if I do my list equals list tup2 and then do my list, as you can see now it's in square brackets, and we could just check and do my list, and now it's a list. Okay, so I'm just going to scroll down here, and what we can do is, let's say we want to convert that back into a tuple. Well, we do tup2 tuple, not list, my list, and then do tup2, and now it's converted back into a tuple. Okay, so let's say we do tup3 equals, in this case we can also have, just like lists, nested tuples. So 10, 10, and then we could do 2, 3, 4. We'll do 2, 3. As you can see, we have these two nested tuples, and we can index them. So we get the first nested tuple, and if we do 1, we get the second nested tuple. And let's say, for instance, we do tuple 4, and that's going to be equal to, let's say, 120, and we can put some strings in it just like we can with list. Dog, true, false, 9.1234, and so we put a negative 30. So we can put different types of data into a tuple just like we can with a list. And there you go, we have 120 cat, dog, which are two strings, two Boolean statements of true and false, a float, and a negative integer. Okay, so let's say we were to actually modify this. So we'll add in a few more. So another 100 here, another 20, another 20, another 20, and we'll add in another true, another true. We'll do one more cat here. Okay, that's fine. And I missed out the comma there. There we go. Okay, so what we can do here is use the functions. So we do dot tab, and as you can see, we only have two functions, we'll count and index. So if I were to do, let's say, index first, and I want to see where the index is for cats, I get it at 6. So if I were to do 2, 4, 6, I get cats. Great. And if I were to put in something else, like say bird, I get an error here, value error, because there's no bird within this tuple. But if I add it, say bird, then you get it at index 15. So if I were to do 15, then you have bird. Okay. Now moving on from index to counts, let's see how many we have of 100. There should be 2 as the output, and we have 2. And if I have to do 20, we should get 4. And if I have to do cats, we should get 2. And we get 2. Okay. So moving on from that, let's say we want to do arrange this time. So tuple 5 equals tuple range 0, 21, and 2. So we're incrementing by 2 each time. We'll do tuple 5. And as you can see here, we have a tuple for the range. Normally, we should just do this without the tuple there. And it would just do the list. Now it's a list. Okay, so just put this back to a tuple. And it's in the parentheses here, so it's a tuple. And let's say, for instance, we wanted to do my list, and we wanted to, let's say, grab 200 and change that to hello, and then we do my list, and then we've changed the elements within the list, which means that it's mutable. The elements within the list are mutable. However, if we were to do this with, say, a tuple, let's say we do tuple 4, and if I just scroll down so we see all of them here. Let's say we want to get rid of bird. So if I do 15, we get bird, and I want to change this to hello. When we run this, we get type error. Tuple object does not support item assignment. And what this means is that the elements within a tuple are not mutable compared to a list where the elements are mutable. Hence, we were able to change the 200 to a hello string. Okay. And Lastly, if we go back to tup4, what we can do is say sum, and this is a Python built-in function, sum. And what this is going to do is count the number of values. In fact, actually, let's just do tup6, 1, 2, 3, 4, and then we run that, and then we do tup6, and then if we were to sum that, we'll get 10 as the output, 10. However, if I were to do true, true, and false, what do you think we're going to get as the output here? Well, remember that true, the numerical equivalent of true is 1, and the numerical equivalent of false is 0, so we should actually get 12, and we get 12 here. And if I were to do tup6 dot, let's say we count 1, we get 3 because there's 1, and then true and true here are basically the equivalent to 1, so we get 3 as the output for counts. And if I were to do 0, we get 1, and in this case it is false, because false is equivalent to 0. Okay, so that concludes my lecture on tuples. I hope that's been insightful. If you have any questions, feel free to ask in the Q&A. Thanks. Welcome to Dictionaries lecture. So dictionaries consist of keys and key values separated by a colon. And dictionaries, also called dict, can contain strings and numbers, tuples, lists, sets, series, data frames, and nested dictionaries. So we'll start off with our very first dictionary of D1 equals in empty curly brackets, and then we do type D1, we get dict, which means that this is a dictionary we're dealing with. Okay, so let's fill this empty dictionary with keys and key values. So we do D1 A, which is going to be our key, and then the key value of 10, and then B equal to 20, and then C equal to 50. We'll do D1, and we have our first dictionary, where we have the keys of A, B, and C, and their respective values of 10, 20, and 50. And let's say we just check each of them. So as you can see, we have 10, 20, and 50 for C. But let's say we want to change this value of C, which is 50, to, let's say, 1,000. Well, we just simply do this, assigning it a new value, and then we do D1. As you can see, it's gone from 50 to 1,000. Okay, so let's say we create a new dictionary, and we'll do robots, 40, and we'll do car, 50, toys, and as you can see here we have car 50 and robot 40. Now if I were to do .tab, you have all this list of available functions and methods that we can apply to our dictionary. And the one that we're going to apply at the moment is updates. If we just run this as it is, we just get function dict.update. So we want this to run, we have to put parentheses here. And some of them don't take any parameters, but in this case this one does. So just do the shift and tab and you'll get some information about the function in question. So it says docstring and type built-in function or method. So what we need to do is put in D1, and then we check toys, and now as you can see the dictionary has been updated with D1 added into the toys dictionary. So you have A, B, and C, car, and robot along with their respective values. Now let's say we wanted to do toys.values. As you can see, we have the values, but we can't actually index them. So if I do 0 to get 40, we get a type error. And the way to go about dealing with that problem is we can convert it to a list or a tuple, and you get 40, or I could do a tuple. If I simply remove this, you can see it's a tuple with the parentheses here, or a list with the square brackets. Okay, So moving on from that, let's say I do toys.keys, and you get all the keys, robot, car, A, B, and C. What else I can do is, let's say I wanted to get rid of A. Well, what I do is toys.pop, and then A, then I do toys. And as you can see, A is no longer a key, and the value is no longer there either. Okay. So, moving on from that, let's say I wanted to create a new dictionary. So, maze, we'll do K1 colon list range 4, and then K2 for our next key. We'll do a tuple this time of 4 and 8. And I should actually do range 4 and 8. And then I'll do K3 colon 1, 2, and 3. And then I'm going to do a nested key here. So we've got K4, and I'll do colon, and we have 1, 2, 3, found you. I'm going to put a comma here, and then I'll do 4 and 5, and I just need to put parentheses around one of them here, so it should be this one here. Okay, that should be fine now. We do maze. Okay, so you have your maze. So this is a dictionary, and what I wanted to do is get the found you string. Well, what we do is maze, and then we do K3. So we do K1 and K2, we'll just simply get the list and the tuple, and we don't want that, we want to get K3 first. And then we want to do free, because 1, 2, and 3 are the 0, 1, and 2 elements, and then you want the third one here, so 0, 1, 2, and 3, and then we'll do K4, and then it's simply a case of free, and then you have found you. Okay, so that concludes my lecture on dictionaries. If you have any questions, feel free to ask in the Q&A. Thanks. Welcome to lists exercise. So in this exercise we have a total of 6 tasks. The first one is add all dictionary values together. So what I want you to do is simply work with this code here by copying and pasting it into an empty cell, and then generate this output of 77. Okay, so the hints are for this dictionary: use the vowels method, use list, the number 3, use the built-in Python function eval to convert a string to a number. The number 4, use list slicing with appropriate index to grab the numbers and add them together. And then number 5, use the int type. Okay, so this should be straightforward for this particular dictionary. All you're doing is grabbing the string values and then converting them into actual integers. Or in this case, a float, but then ultimately you're going to have to convert them into an integer as a final output. Okay, so moving on to task 2, which is use comparison operators in a list. So all you have to do, likewise, is copy and paste this code into an empty cell, and then do comparisons between each of these numbers, and then between this string with this tuple, and then with these 2 numbers here. And all you're going to be doing is using these operators. So the first 2 are comparison operators, and the last one is a membership operator. And the desired output is true, true, false, true, false. And the only hints are that you're simply using the operators that I've shown above. Okay, so moving on to the next task. So task 3 is len values with comparison operators. So what you're doing is likewise copying and pasting this code into an empty cell and using these two comparison operators, greater than and less than, along with the len built-in Python function. And you're going to be doing the comparison operation in order from K1 to K2 and to K3. So in that order. And the desired output should simply be true. And the hints as follows are: number 1, use the two operators shown above, use the len built-in function, and number 3, use the operators in the same order as the dictionary keys, which are K1, K2, and K3. Okay, so moving on to task 4, update dictionary. So we have a dictionary here called life stages, and simply copy and paste this code into an empty cell, and then I want this desired output where we have also 5 and 6 as the keys and adult and big kid. So the hints as follows are: number 1, create a new dictionary called midlife with keys 5 and 6 and the key values of adult and big kid. And then number 2, add midlife dictionary to life stages using one of the dictionary methods. Okay, so moving on to task 5, add all the values from list. So we have a list here called nest1, and it contains a nested tuple, a nested dictionary, and a nested list. And you're going to be using sorted and eval. And what I want you to do is simply add the values from 3, 300, 30, and 500 together to give this float number of 833.0. Okay, so the hints as follows are: number 1, add 3, 300, 30, and 500 together from each of the nested tuples, dictionaries, or lists. Then number 2, use the only two built-in Python functions shown above. Then number 3, use the Python built-in function sorted for K1. K1 is the key here. And then number 4, use the nested dictionary K1, index only by -1, not 2. And then lastly, number 5, use the floats so you can have a float instead of an integer output. Okay, so moving on to our final task, which is the toughest of the lot, and that is add all list values into a string. So what we have here is two variables, prices and sentences. And what I want you to do is that this variable is a string, this variable is a list, and this one here is a string, or specifically a doc string because it contains triple, double quotation marks on either ends. And what you have to do is, firstly, for prices, I want the desired output of this 9, 4, and 2.5, and then you're going to add these values together and generate this output of $15.5, along with pizza, chips, and drink. And also you'll have to remove these characters here, so hashtag, exclamation mark, slash, question mark. So you're going to have to remove those. And the hints as follows are: number 1, use the format function. Number 2, use slicing and stride. Number 3, use the eval, len, and string. Number 4, add all the string numbers from the prices list. And number 5, use the replace function twice. That's very important. Okay. Well, good luck. Hopefully you'll be able to get these tasks completed, but if not, don't worry. I'll be showing you in the next lecture with the solutions. Thanks. Welcome to List Solutions. So we have a total of 6 tasks here, and hopefully you've given them all a try. So we'll start off with the first one, which is add all dictionary values. Okay, so what we want is the output of an integer, which is 77. And all we have to do is toys.tab. We'll do values, and as you can see here, we have all the values, but this isn't actually a list. It's just a subset of the dictionary. So what we need to do, if I were to do, let's say, index of 0, I get an error, type error. So the way to get around this, if we want to do actual indexing, is convert this into a list. Okay, and now we can go about doing indexing. So we do 0, we get the $sign as well with the 40. So we don't want the $sign because we can't convert and then add this particular string when it contains a $sign. So what we can do is, let's say we do 1, we get 4 only, but we want the rest of the number. So we do colon, and now we have the string of 40 without the dollar sign. And then we can convert this into an actual float number. So we have 40.0. Okay, now we can do some arithmetic on this. So we'll do plus. We're essentially repeating the same process here. List toys.values 1. So this time we're going to grab 25. And then, of course, 1 colon to get rid of the dollar sign. And then we have 65. I'm just going to convert this into num as a variable. And then we'll do plus. It's actually not going to give the output we're looking for at the moment. Just give 12, but just for the sake of keeping it on another line, so it's a bit more clearer. Val list toys.values 2, of course. So we're grabbing 12 this time. 1 colon, and we get 12. And if I were to do int to wrap this round, run that, and then we do num, and we get 77. Okay, great. So moving on to our second task, use comparison operators in a list. So this is pretty straightforward. All we're going to do is get this output here of true, true, false, true, and false. So how do we get this output here? Well, all we have to do is we want 2 trues here, which I've got here as well. And of course, 10 is not equal to 4, so it's going to be true. 50 is equal to itself, so that's going to be true. And then, of course, 90 is not equal to 10, so that's false. And C, the string, is obviously in this tuple, so we do in. And lastly, this is going to be false, because 100 not equal to itself is obviously false. And we have the exact same output. True, true, false, true, false. Okay, so moving on to the next task, len key values or comparison operators. Okay, so what we have to do here is do len, and I'm just going to scroll down to make some space, and we'll do films k1, and we'll get 17 because there's 17 elements within this particular string. And if I do greater than len films k2, and that's true because there's more elements in the k1 than there is in the k2. But if I do greater than len films k3, we get false. And that's because matrix only has a total of 6 elements, whereas Ninja Scroll has a total of 5, 11, 12. So this seems to have about 12 here. So just change this to less than, and we get true, which is what we wanted here. Okay. So moving on to task 4 now, update dictionary. And all we have to do here is create a new dictionary called midlife. And we'll do 5 colon adults, and then 6 colon big kid. And then we do life stages dots tab, we do update midlife, and then we do life stages. And we just scroll down a little bit to check, and what we have is adults and big kid. Okay, so we've updated it just like we had with the desired output, adult and big kid. Right, so moving on to our next task, add all values from list. So it's a little bit more tricky. I'm going to be using the sorted and the eval. I want the desired output of a float, which is 833.0. Okay, so what we have to do here is nest 1, and I'm going to index this list by 0, and we grab the tuple, and then we want 3, because we're adding 3, 330, and 500 to get the float value of 833.0. So if I run this, we get 3, and then I'll just show here, I'm going to just convert this into, let's say, K1, and then we'll do sorted nest 1 this time, because instead of it being 0, this is 1 for the dictionary. And then we're going to do K1, and if I do K1 here, we get the sorted values of the lowest to the highest, but we want 300, so if we do -1, we get 300. So I'll do K1 here, 303, okay, and then we'll do K2 equal to nest1, sorry. Then that's going to be 1 again because it's a dictionary, and then we do K2, and if I do K2 here, okay, and then we want to get just 30, so we'll do plus K2, 333, and then lastly we'll do K3 equal to nest1, and we want to get 2, so we're grabbing the nested list here, and then we want 1 for the 500. Well, this is a string, so we just simply do eval and convert this into an actual integer, 500, and we do K3, we're 853. Okay, great, and then we just want to convert this into an actual float, 853.0, which is what we have at the top here. Okay, great. So we're moving on to our final task, which is pretty tricky. So add all list values into a string. Okay, so we want to use these two. In this case, it's a list and a doc string specifically, not just a string, but a doc string because it contains triple double quotation marks on either end of this string. And we want to have the desired output of the prices, 9, 4, and 2.5. So this one's pretty straightforward for prices, and we'll start, if we do 2, we get 9, but if we do : 3, we get 9, 4, and 2.5. So this is starting at 2, and then we're going up by 3 each time. So this is 0, 1, 2, 3, and then this is going to be 0, 1, 2, 3. Hence we get 9, 4, and 2.5. Okay, and then moving on to the actual string itself, we'll do sentence.formats, and then we want to fill in and make sure we have the outputs of pizza, chips, and drink came to. So we've got drink in here, so we do pizza, chips, and then we want the $sign here came to. So we have the $sign, drink here, chips, and pizza. Alright, so what else we need to do is dot replace. Let's just get rid of this first, these characters that we want to make it look a bit clearer without them. So we'll get rid of the question marks. Okay, so they're gone now. We'll do dot replace again, and we want to get rid of this. Okay, so it's a bit clearer, but we need the actual numerical value of $15.5. So what we can do is use this list, and we'll create, let's say, pizza equals eval. It's going to be prices, and we'll do 0, and then whoopsie, chips equals eval, but actually that's going to be a bit confusing. Just do P and C, and that we'll do as len, because we need to convert the 4 into an actual number 4. Prices 1, and then the last one is D for drink. So P for pizza, C for chips, and D for drink. Let's eval prices 2. And that should be fine. I'll just check what I've done wrong here. A is not defined. Where is A not defined here? Oh, I see. I see what I've done wrong here. I need to actually convert this into, let's call this cash. Let's call that cash. And now, if I do P equals cash, then I will have, let's just do eval cash 0, and then do C equals len cash 1, and then the last one is D for drinks, eval cash 2. So this should work now. Okay, great. Just check the prices. Whoops. Should be P. So 9. C should be 4. And D is 2.5. Okay, great. And then we can just do the calculation here. So what we want is plus string, and we're going to do P plus C plus D. Okay, great. So the bill for the pizza, chips, and drink came to $15.5. Okay, I hope that's been helpful, and if you have any questions, feel free to ask in the Q&A. Thank you.